Hello, friends. Part 2 of your podcast in section 3.2 in your AP Stats book. We left off right here, and the next idea, and this may be new, is the idea of extrapolation. Okay, and extrapolation is a simple way of saying that I am making predictions with my math model past the range of data. Uh, so, if these red dots are the points that I know, so all the x values that I know are between these two numbers. This math model should be, and actually the correlation will tell us how good the math model is, in between the lowest x and the highest x value. But if I make predictions out here or out here, outside the range of x values that I know from the data set, that's called extrapolation. And I don't want to extrapolate because I don't know how this pattern would change. Might it stay the same? Might it go up? Might it go down faster? I don't know what's going to happen above or below this range of data. So extrapolation, again, is making predictions from a mathematical model that are outside the range of variables I know for x. And actually, I should call them the domain of variables because x is the domain. All right? So this is just another same activity, and this just illustrates the difference between what I would predict from my math model and each value that I actually got. Okay, so this would be, we would call the error because I predicted this, I got this, and this was the difference. Okay, so again, that's going to lead to our discussion of residuals in a little bit. So what is this regression line? Well, it's actually more technically called a least squares regression line. Taking that idea of the error, when I fit a line in to a set of points like this, for every actual point of data, I can draw a line, which is a distance between that point and my regression line, my model. And that distance, some will be short, some will be long. You can see this one is right on the line. And for every one of those distances, I can square that area. And of course, that square takes the negative out because this one's below, this one's above. And if I add up all the areas of all the squares that come from the difference between my model and my actual data, the least squares regression line is the line where these areas all added up are the smallest they can possibly be. And we arrive at that number through a formula, which is right here. So I guess the most important, first and foremost, is this is the mathematics of where that regression line comes from. And you should be able to, on the calculator, put in data, calculate a least squares regression line, and find the correlation. But if you're given summary statistics like this, like you almost always are on the AP exam, you should be able to plug this information into this formula. Actually, this one first, and then you take your answer with B and put it in here, and write the equation yourself. So that's what we do here. You can see we take the x bar. We don't take the x bar first because we are going to start with finding B. So we take correlation first, which is right here. We plug correlation in there. We take the change in y, right here, and the change in x, which is those are the standard deviations. And when I plug the actual numbers in here, I get a value for b, which is my slope. So if I'm going to interpret slope in terms of this problem, okay, this is how much whatever the y changes per 1 unit of whatever x is. So that's the sentence I want to be able to write. And now once I know b, now I can use my x bar right here, use my y bar right here, because the averages, the means of the x and y data have to be a point on this line. And then it's just algebra to solve for a, and there's my line. All right, so that's the big thing we're looking to accomplish here, is understand what a least squares regression line is, how to get it by the formula or on the calculator. We'll see you in class tomorrow.